So, so here is our production uh, issue. Um, so you can see that our production probabilities have a discrete distribution, right? So 5% of the time it takes 5 days, 30% of the time it takes 8 days, 5% of the time it takes 11 days. This is going to be important to us when we're trying to figure out the lead time. We're also told that our distribution of the yield, each batch is not the same size. It can be as little as 600 ounces and as much as 1,100 ounces, and that it'll pass inspection 80% of the time. So I'm going to start off by assuming, or not assuming, I'm going to start off by just postulating that we're going to have, I don't know, let's say 15 batches. Okay? And based on those 15 batches, they're all going to have specific uh, days of production. So how do I want to model this? Well, let's start off by looking at the discrete distribution, all right? So I'm going to call up defined distributions from at risk, and I'm going to pull up the discrete distribution here. Hello, come on. I'll just select it. All right, so here's what the discrete distribution looks like. It has a value of x's and a value of probabilities, all right? So in other words, for us, here is the column of x values. No, oh, I see what it's doing. Hang on a sec. All right. So here's the column. It's still trying to do that, isn't it? Okay. Let's do it this way. No, it still doesn't want to do that for me. All right, so there we go. Okay. So let's go ahead. It's good. No. Ah. Don't you just love it when Excel takes over? There we go. Let's maybe do, there we go. All right. So now let's try it again. I was like, risk discrete. And how does it want me to list them? It wants the x values first, and then the probabilities second. So the x values are the days, and the probabilities are the probabilities in this column. And so the first batch took 8 days to produce. If I hit F9, there we go, 10, 9, 9, 7, 6, 7, 6. All right, so it's giving me different days of probability. All right, the yield. All right, now we've used a triangular distribution before, have we not? So here, this should be very simple, risk triang. Well, before I do that, let me go ahead and give it some range names. Do this just because it'll make it easy for us to understand what's going on. All right, so risk triang, minimum, most likely, and maximum. All right. Now, pass. Here, it's really a yes or no answer, right? And we can do it a couple of different ways. We can use an at-risk variable, you know, risk between, or risk uniform rather. But keeping in mind that we've got that student model limit of risk variables, at-risk variables, let's just use an Excel function, because that way it's not going to affect us. All right. So here is going to be an if, and the value is going to be like this. If rand is less than, okay, so what value should it be less than? If it's less than 80, then what? It would pass, right? Because if it's the 20% is going to be the number greater than 80. Or we could say if it's less than 20, it fails, otherwise it passes. Either way would work, would it not? So I'm going to go what to me is the most intuitive way, and that is by choosing the probability of passing, which is in this cell here. So if it's less than 80, then the value is yes, otherwise the value is no. We could make it equal to, sure, but don't forget it starts at 0, right? So, but we can make it equal to. I'm not against that. Okay. So now, how do we calculate the cumulative yield? Well, the cumulative yield is going to depend, first of all, on whether it's passed inspection. So that's the first thing we have to add. So equals if this value is equal to yes, then what? Well, in this case, since it's the very first batch, it's just going to be equal to the yield amount. Otherwise, the value is 0. Right? And then finally, the question is it enough? Again, it's going to be an equal, is going to be if cumulative yield is greater than or equal to the amount required, then yes, otherwise no. Okay, so there's our first batch. It took us 6 days, and it produced 755 ounces of product. Now, notice when we have the column that says enough, we have an automatic switch to turn off production when we reach the maximum that we need. So now, rather than just using a risk discrete, what I'm going to do is I'm going to say equals to if this value is equal to no, then I'll do risk discrete. And again, the x values come first, and the probabilities come second. Otherwise, if it's already produced enough, then I can just put an NA here. Okay. So what I've done is I've said, okay, if I have not produced enough, then I'm going to run another batch. If I have produced enough, then I can stop. I don't need to do anything else. Okay, now my yield is going to become a hypothetical as well. If this is equal to NA, then my yield is also NA, right? Otherwise, it's going to be risk triang minimum, most likely maximum. Okay. Similarly, my pass now is going to be, again, if the yield is equal to NA, then the pass is NA. Otherwise, and now we have a compound if, don't we? If RAND is less than or equal to 0.8, and now I'm going to make this an absolute value because I'm going to want to copy this down from this point forward. Then the answer is yes, otherwise the answer is no. And I need another point. There we go. All right. Now my cumulative yield, again, I'm going to look for an if, and I'm going to come all the way back here and say if that's equal to NA, then my cumulative yield is equal to NA. Otherwise, it's equal to the yield plus, what's that, E25? So and then do I do what? We've already got that here, right? Ah, okay. Thank you, thank you. Otherwise, if, thank you, this equals, quote, yes, then it's that. Otherwise, it's just E25, right? So if the second batch just didn't make, then we'll just pull down the number from above. Thank you for catching that. And then, can I copy this down? I can if I make that absolute, right? Okay. Now I should be able to copy this entire row down as far as I need to go. I'm going to copy it all. If I did this right, all right, so why did it give me a, you know why? Because I didn't make the risk discrete. I didn't make the risk discrete an absolute reference, right? That has to be absolute. 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 Wow. Okay, so it actually took 15 batches for me to make, right? So there's a situation now where it took fewer than 15 batches. There's one where it only took 10 batches there. Okay. All right. So now maybe what I should do is I should extend this down a little further, huh? What do you think? Maybe go down to 20 batches? That make better sense? Okay. Now, how do I figure out how many batches it took to produce the, the quantity that I needed? Because that's one of the things I want to know. I want to know total batches and total time. So how am I going to get those numbers? Pardon? Oh, you're talking about in this one, in this column right here. That might work. Let's try that. Equals to count if this range, quote, equals to NO, and then add 1 to it, because by that time it's a yes. All right, so there's total batches is 10. So let's run the simulation again. This time it should be 17, and it is. Try it again. This time it should be 10 again. This time it should be 9, 10. Okay, looks like that works. What about total time? Well, let's try that. You're basically saying just sum this, right? Well, do the NAs cause any problems if I do that? No, actually they didn't. Let's see if that's really correct though. And there's the sum down here says 90, so that is correct. What if I run it again? 109, and it is 109 in this case. 74, and it is a 74 in this case. Okay. So now what I'm going to do is I'm going to create names, and I'm going to make each one of these now an output variable. Total batches is an output variable, and total time is an output variable. So now I've got two output variables that I'm going to keep track of. And what I'm going to do now is I'm going to run this simulation. I'm just going to run it for 1,000 times. Okay? So let's see what the average total time is for this simulation. Okay, the mean is 94 days, minimum is 64, maximum is 163. Standard deviation is 15.479, but I'm probably more interested in the 95% confidence interval, right? So my 95% confidence interval is between 70 and 130. So how long, keeping in mind now that if I'm going to produce this product, I have to deliver. Otherwise, I'm in violation of my contractual requirement. What kind of lead time do you think I should quote for this product? Should I quote the average, which is 94 days, or should I quote some other number? it depends on how much risk you're willing to take, right? Here's what's going to happen. All right, so you've got a really uh, how long the microphone's been disconnected. Hopefully it just got disconnected, but we'll find out. Still a few bugs in the system here.